So we have started last time talking about programming Gaussian elimination. If I asked you to do things on the paper, you would go and write down your system, and then you would kind of eyeball what you multiply first row with, and then kind of cancel the coefficients underneath, right? So now we're actually going to do the same. It's just we're not going to be eyeballing any coefficients. Computer is doing the work, so we can just come up with whatever scheme works and just apply it to all the rows, okay? And move through the matrix to reduce. So I asked you to actually do this on paper first. Essentially, I don't know if you still have that piece of paper, but just this first row, just this first action, multiply row 1 by A21 over A11 and subtract from row 2. So if you can just do that and see what this row 2 will become. Okay. It's a little bit of an ugly writing, but ultimately the computer will do that for us. We just need to kind of figure out what the algorithm would be. So just do that exercise, and then we're going to jump into programming it. If you have done it, you can do the same for this third row. And what I'm doing is I'm being smarty pants and here just renaming my new coefficients in the process. I tilde on top.
Are we going to be doing any coding? Are we going to be coding?
Yes, right after this. So whatever it is that you get on the paper, normally we just do actual numbers so it doesn't look as abstract, right? It actually is actual calculation. Has everybody gotten that ugly second row? After I multiplied this row by A21 over A11 and subtract from row 2. So I'm itching to actually program that.
Second and third rows?
Just do one. Let's get to it. So let's actually get a new Python script. And I'm going to go through the steps. Instead of writing the entire piece of code on a piece of paper, I'm just going to go through the thinking process and try to apply it on a specific case and go step by step and make this a journal. So initially, I'm going to start with a 3x3 system that we've already solved. Okay? That's the one we solved by hand. And in that 3x3 system, my A was NP array, so the moment I type in NP, I need to import numpy as NP. So let's just type in the matrix A that we've already had, and that one was the following one. -3, 2, -1, that's my first row. 6, -6, 7, and then 3, -4, 4, Whoops, and I already managed to type in something. Oh, that little detail. You see, I skipped in the middle of it. I skipped to import. Okay, so this was my matrix, and then my B, the right-hand side, was -1, -7, -6. Okay? And we know that Python doesn't really care for column and row arrays as long as there are 3 elements. Mathematically, B should be a column vector, but it doesn't matter to Python. And what we actually want to, we know that there is actually a built-in ability in linear algebra submodule of NumPy. There's solver that actually solves this problem. So this is 2, 2 minus 1 that we've worked for. We actually computed it by hand. So we need to get this, okay? Today we're going to program and write this code on our own that will get 2, 2 minus 1 hopefully at the end. So this is built-in NumPy solver. We need to get the same result. So let's do this step 1. Multiply row 1 by A21 divided by A11 and we subtract from row 2. Can you write that down in NumPy with this matrix? And we're going to check whether we got the 0 where we were supposed to get it for. So we're just going to step 1, multiply row 1, and I'm going to translate it to Pythonese immediately. Row 0. Okay?
Just a little bit up to show what you did before that.
So I was just typing in and I was just kind of looking at what do I need to get by having a known solution. I also got this 2, 2 minus 1 by hand. So ultimately, if I knew no solvers, I would have a small example done by hand that I'm using to check my numerical program, right? So you kind of always have to have that when you're building a solution. So let's multiply, and I'm translating this row 1 is essentially row 0 in Python world. So I'm going to multiply row 0 by, it says, A21 divided by A11, which if I'm starting from 0, it's a A10 divided by A00. Everybody agrees? So A10 divided by A00 and subtract from row, and it's not now row 1, but it's row 1. So it's not 2 anymore, but it's row 1. Okay. So this second row, and I'm actually going to replace this second row in matrix A. So I'm going to replace A first, and I'm going to work on B separately. So right now I'm just working on A. So basically I'm going to take this row and say this row is equal to this row minus this coefficient times first this row, okay? So this coefficient, I'm just going to give it a name, and I'm just going to call it C to shorten my writing. How do I isolate row 1 from matrix A. What do I type in to get the entire row? So this is my row 1, okay? And I'm just reading what this statement here says, which is not a bad idea when you're typing code. Just give yourself what you're doing, and you'll be grateful later that there was actually something typed in. So I'm going to subtract from row 1. So I'm going to take this row 1 becomes row 1 minus row 0 times this coefficient. So it's A row 1 what is my row 0? Yeah? This is thanks to vectorization in NumPy. I can just work on the entire row, right? Let's see that we did what we were supposed to do. And print myself matrix A. Do I have 0 where it's supposed to be? Cool, I did something right. I'm going to continue by hand and work on this. I have 3 operations to do it. And I'm going to do it by hand. And then I'm going to look how to create some loops that go and work on matrix A regardless of its size. Yes. Here I have a 3 by 3. Everything is easy with 3 by 3. I can do things by hand. But I want my program to work with any matrix A. If I give it 100 by 100, it should go through. Okay? Let's give that a shot. So for now, until I see the rule, I'm actually going to do the same thing with this row 3, which was suggested in this slide. Now multiply this first row by A31 divided by AY1 and subtract from row 3, which basically says take this row, okay, and replace it by this row minus this new coefficient times the first row. And I just have to take the coefficient that works, okay? So the coefficient that works is actually suggested here, so I'm going to do a good old cut, copy, paste and replace with now my coefficient. My third row is in position 2. Oops, not 20. And instead of this row 1, it's now row 2, which is the third row in the matrix, if you start counting by 1. Is this correct? Yeah? So basically, key things to replace were this 1, 1, 1, now became 2, 2, 2. Yes? The moment you're consistently replacing 1, 1, 1 to 2, 2, 2, there's a way to define a variable, okay, and then have a for loop for that variable. Okay? I'm going to get that to a second. Because what I want this is to work for all of the elements below that first pivot position that I have in the matrix, right? However many there are. So I will need a for loop for that. And then I also have to move laterally because this is a matrix. So to process all of the things that I need to process, I will need a nested loop. But let's see for now that this actually works. So I'm double checking that things work. Woohoo! So my column 0 is done. Yes? I'm going to give myself a mental note. Process column 0 under element, pivot element A0, 0. because that's my key element that I'm using, right? This element here was the key element that I'm using to kind of destroy things underneath and make them 0. So now, so far, I've used Python just as a glorified calculator to type in what I would normally do by hand, right? In my process of this, we call this forward elimination. Of course, I get one phone call a day, and that happens, if that phone call happens at all. And that happens during, and it's from suspected spam. Everybody else that I know actually knows that I'm not available at this time. Okay. So this has processed my column 0. Now, what would I, if I was doing things properly, I would have in my processing also worked on my B, right? Because I would have created that augmented matrix. So what I'm going to do now is I'm going to just correct myself and go and work on B as well. So here underneath, okay, I would just process B, so where I had A of 1 something, that's where I would have B of 1. So my B of 1 would simply become B of 1 minus C times B of 0. B is simpler. B is just a vector. What would that become here for the second row? Or row 2, which is the third row altogether. B of 2 is equal to B of 2, and I can write it so that it's kind of parallel with the yeah. So I can see if I make errors. And print B for a check. Cool. So that is my column 0. Now I would normally go and move on to this pivot element, okay? And then find a coefficient to multiply this entire row and subtract it from the row below, right? To get a 0 here, right? Yes.
What was B supposed to change or no?
It is supposed to change, yes.
Did it change? I think it's the same.
Did I B1, B2? Let's see. This is my B. Let's just re-execute everything. So B of 1 is supposed to be, yes, it did. Maybe it needed executed twice. Sometimes this thing needs just do it twice before you think you've done something wrong. That's the best explanation I have so far. There's sometimes communication in updating what is in the memory of the web browser, or what's showing in the web browser versus what actually has been done in Python. Because web browser is not Python. Web browser is just kind of getting information from Python to display. Okay. So now B has changed magically. Okay. So now let's actually do this. So I'm going to proceed in the same way. So I'm going to actually copy all of this. And I'm going to just make appropriate changes. So now it's multiply my row 1. And everything kind of increases by 1. Because my pivot element now is A11. So again, my pivot element is now in this new matrix, not in the old one. It's this divided by this, right? So that is A2, 1 divided by A1, 1. And I'm replacing what is row 2 with row 2. And now it's times row 1. I have upper triangular matrix. That's what I need at the end of forward elimination. Yes? And what I would now proceed with is back substitution. But before I do that, okay, I'm going to make a loop out of this. Okay? Double loop. Because I need to go down my column and then move over, go down that column, move over, and down that. Now columns keep getting shorter, but it's nevertheless nested loop, right? So go down this column, then move over to this pivot element, this column. Meanwhile, I'm going to ask Ningyu to create us a very nice 4x4 system that has nice solution. If I start typing in something now and define it on my own, I'm going to define a 4x4 matrix that has rank 0. So please, if you can just maybe extend this one to a 4x4 so we can have an additional test. So kind of reuse as many numbers as you can from this example that we've solved in class. Right? Or just create us a nice 4x4 system. Okay? Get a nice matrix A that has a full rank, okay? And multiply it by a nice vector X to give us a vector B. Because if I go and multiply my 4x4 matrix, if I create the matrix 4x4 on my own, it's not going to have a full rank. Do you see where I'm going? Okay. Cool. So just get us something nice. All right. Because we want to test our something on something that is 4x4, okay? So let's do a loop, okay? So first things first here, okay? This is my entire column 1. So obviously I see something going on. I'm processing first. I'm under 0, 0. And I'm processing row 1 and 2. Okay? Under 0, 0, I'm processing row 1 and 2. Yes? So let's just do a loop that just does that. It works with column 0, but it's just doing rows 1 and 2. And I'm going to call that a K. K, K. K, K, and I'm going to delete this for now. If you don't want, you can just copy this over into the next cell if you don't want to delete it. Maybe I should do that too. I could just write it down on a piece of paper. Or just email it to everybody on Canvas. Create an NP array of it and please. All right. So I'm just gonna copy this entire cell. I'm not gonna destroy my work. Whoops, I didn't need this. Okay. So I'm gonna create K out of this. And that K is going to be a for loop. That K needs to go over 1 and 2, right? So I'm going to say for K in range 1, and I need 3 for that. That should do the same thing. And the only thing that I need to remember is redo my A and B, because otherwise I'll be working with the old one. See why? Because I'm changing it in place, so I don't want to work with the old one. So my for loop is now working for this row 0, or column 0 rather. Now this thing, should I stop for a moment? Let me stop for a moment for it to catch up. Well, I'm going. But guess what? I've seen this before. By the nature of me sitting in front of you here. Is everybody comfortable with me replacing those 2 steps? I knew it was useful to actually keep it that. So I had these 2 steps, and I just replaced, instead of typing in 1, 1, 1, 1, 1, 1, wherever I saw 1, and then it became 2, I changed it to a K, and that K goes from 1 to 2. That's what for loops are for. Yes?
The ones you change.
So I had this process in processing column 0, right? I was working on row 1, and then I was working on row 2, and I can see that whatever was 1 is 2 in my second go. Does everybody see? Wherever I see 1, I now see 2. 1, 2, 1, 2, 1, 2, 1, 2. Yes? So when I put a K instead of 1 and 2, then my K is going first from 1, then 2, and that's range 1, 3. Range 1, 3 has 2 elements in that, 1 and 2, and 3 is not there. I'm mad at Python for that, but doesn't matter who asks me, I didn't create it. Okay? It'd be really nice if this was just range 1, 2, but oh well. There's always something you don't like, and there's always something you like. So there we go. Hopefully it balances. So hopefully we have a mass balance there. All right. Everybody comfortable with this for loop? Cool. Now, this thing is kind of doing the same thing, just with a different column. Yes? And that column is now, instead of 0, I have ones where I had zeros. And another thing that happens is that this is only 2, it's not 1 and 2. So how many elements I process depends on the pivot element. Now, one thing that I know here, okay, if I wanted to, is that this K, okay, is actually happening. So for every row below pivot element, or process every row, I'm doing something for every row below this pivot element. So let's give this pivot element a name. I'm going to call it my column. Let's give it a name. It's a J, and right now J is 0. And wherever I see 0, I'm going to just say J, 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 J. I've done nothing. I just kind of replaced it. There's one thing that I didn't replace that I should for this to work. So my J is right now 0, 0, and I should, I guess, do it in the comment as well. So how many elements do I have, or what are the rows below element JJ, generally? So if my J is 0, I have 1 and 2. If my J is 1, I have only 2. If my J is 2, I have nobody. So then where I start depends on my column, J. So this 1 is actually J plus 1. Yes? Below is plus 1 in matrix world. Row below me is whatever it was plus 1. So then I have everybody sees this? So if my J is 0, I have 1 and 2, so that's going to work. 0 plus 1 is 1, 3, right? But if my J is 1, this is going to go from 2 to 2. Going to be only 1 below. 1, 1. Now let's imagine this J is equal to 1. So that's my next element over. What is going to be here? K will be in range 2, 3, which is only one element, 2. Okay? So this is going to be 2. So now replace this with 2 and this with 1. 2, 1, 1, 1. 2, 1, 1, 1. 2, 2, 2, 2, 1, 1. 2, 2, 2, 2, 1, 1. So this loop would work for J is equal to 1 as well. So can I throw in an outer loop there? Let's see if we still get what we're supposed to get. There's plenty of chances for typos here. Seems to be working for this. Two.
You just erase a bunch of stuff.
I erased what's coming underneath because I replaced it with the for loop. So this for loop executes for 0 and 1, okay? And for when j is 0, that's my first instance, then I have a for loop that executes for 1 and 2. And when j, on the second go, when j is equal to 1, then this for loop executes only for 2. Yes? So this will work great for 3 by 3 matrices, right? Is that a good general function? Yeah? No, it works for 3 by 3. So now I just have to figure out how to change it to work for any size matrix A. And then Ningyu will give us a test problem to test our forward elimination. Okay? So let's do that. So what is this? It's basically how many times I repeat this that depends on the size of the matrix. So I have a 2 here, and I have a 3 here, and size of my matrix is 3 by 3, right? So I'm gonna give myself something that evaluates size. This is now not applicable anymore. So I'm gonna just say, well, Mn is shape, a shape, and hopefully M is equal to N if M different from N give me a square matrix. I haven't programmed things for non-square matrices. Okay. So I'm just gonna print an error or warning right now. I'm gonna deal with it and clean it up later. So basically I have n by n matrix or m by m, however you want to call it. So if my m is 3, right? Just to, if you're unsure what does this do, let's just do it below. Okay, so it's 3 by 3, yes? So then this seems to be 1 less, and this seems to be m. Yeah, this should work. Are we ready to test it?
What did you say after you want MN, A shape, and then print MN down at the bottom?
Yeah, I was just testing what A shape does, just in case you don't recall. But this is good, always good to test, really, when you're programming. Because even when you think you know what you're doing, you do typos. You do typos, I do typos, we all do typos. Question is how quick you are in finding them, or do you have an entire class watching over you not to do a typo? When you're on your own, you don't have that. So this should work for any matrix. Let me make it a function then. Yes? And I'm going to just copy this entire thing. and create the function in my next iteration here. First thing, I'm going to indent it. And then I'm going to call that function, this is just doing forward elimination, of AB and here I'm printing it. I can also return AB at the end. So just to see that it's doing the same thing, oops.
What did you talk at the top there?
Ah, I didn't execute this. What did I do?
At the very top of the.
This one? I defined the function with its name, gave it input parameters, A and B, and I indented the entire code to actually make it part of the function. So indentation, 4 spaces. There we go. And I can now execute that function for my A and B. But Ningyu is about to give me a more complex A and B. Did you post it on Canvas? Yes. If you want to go on Canvas, let's just go there and cut, copy, paste, please. Easier. So let's just see that's for a 4x4. Oh. Copy this. Oh, you're defining B as a proper.
So you indent the 4J in range 2 element?
Yes, entire code that you had previously, you just move in. The one that I copied, yeah. I didn't want to overwrite this because I'm kind of moving step by step, and I want evidence of all steps left because I'm going to post it for you. Okay? Moment of truth. Let's see whether this does the correct thing for a slightly larger matrix. And Mingyu actually created B as a column vector. That's fine. It works either way. So forward elimination, do I have an upper triangular matrix? We did something right. At least our code works for 3x3 and 4x4 matrices, right? Now, I could go and define myself a 6x6 random one, right? It's just in a random one, I don't know that it's giving me the correct result. And this one, we know that we need to get nice numbers at the end, right? Because that's why I asked you to give me a nice 4x4 system, okay? I could work with random numbers, but I have no clue whether it did the correct calculation at the end or not. So these are going to be our 2 test systems. Cool. We have forward elimination done. Questions?
Where did you get this array that you have?
From Canvas. Ningyu has posted it on Canvas because that's just faster. You can copy it from Canvas and we don't make mistakes there. Yeah? Now we need back substitution. Okay? Let's start little by little. We're not going to finish it today. But let's start again step by step. So if I was solving this 4x4 or 3x3 system, it doesn't matter. Okay? I would start, this is my A, and this is my B. Yes? So what is my last X? When I'm solving things, and this is, I have X1, X2, X3, X4, minus 1 times X4 is equal to B4, right? In Python speak, minus 1 times X3 is B of 3. Okay? So that one is my starting point, and I can actually type it in immediately. So let's start working on back substitution.
So is that array that you typed in?
Yes.
Is that under, where did you type announcements?
It's under announcements. And one thing that I didn't do, I didn't return the result. I didn't overwrite it, and I should. So whatever the function returns, I should overwrite because that's what I'm going to be working with for back substitution. So one thing that I know for sure in back substitution is that my last X of 3, or do you want to work with 3x3? Either way is fine by me. I'm just working now with this 4x4 system. It's whatever I had lost here in the matrix. So it's B of 3 divided by A of 3, 3. Oops. Oh. You know, Ningyu, I'm going to overwrite your decision to use a column vector. My life is simpler if it's a single 1D array in terms of typing things. And I still...
You erased one too many brackets.
Boop, boop, boop. No, I didn't erase enough.
No, you still need...
For 1D?
Don't you need 2 on each end?
Nope.
Oh, yeah.
I shouldn't. Ah, I didn't define X. That's my problem. NP of zeros of the same size as B. B shape. Now, so I gotta define my B, define X where we will store results. Define the last element of X. Because in back substitution, that's what I start from. Okay. Now I will take this last element and put it in the row above, and above, and above. And we are going to go and do a for loop out of that next time. Okay? Okay. See you on Wednesday.